Welcome to the deep dive. Today we're looking at a ridiculously tough piece of gear. It's the Kramer CP-AOCH-PF-66.
Yeah, and to be clear, that's a 66-foot 4K HDMI cable.
A 66-foot cable that costs over $500. So our mission today is pretty simple. What on earth justifies that price tag?
Well, the first thing you have to understand is this is not your standard copper cable. This is an active optical cable, an AOC.
Okay, so it's using light.
Exactly. It converts the electrical HDMI signal into light, sends it down the fiber, and then converts it back on the other end. That's key for heavy-duty places, especially anywhere with a lot of electromagnetic interference.
Like medical facilities.
Medical, industrial, you name it. So our goal is to figure out how this thing maintains perfect video quality over that huge distance while being tough enough to, survive a construction site.
All right, let's start with performance. I mean, for that money, signal integrity has to be flawless.
Oh, absolutely. The specs confirm it supports full 4K at 60 Hz with 4.4.4 chroma subsample.
Which is the big one, right? That means no color compression.
Zero color compression. It needs a full 18 gigabits per second bandwidth of HDMI 2.0, and it delivers. And because it's fiber, specifically OM3 multi-mode fiber, this type of cable can push that signal up to 100 meters.
100 meters? That's, what, over 300 feet?
Yeah, 328 feet, something a normal copper cable could never, ever do.
And what about all the digital handshaking stuff? I'm not going to plug this in and get a black screen because of some compatibility issue, am I?
No, you're good there. It has full support for eDIDE, which is how the display tells the source what it can handle. And of course, it's HDCP compliant for protected content.
And you still get your high-end audio.
Yep, lossless Dolby True HD, DTS HD Master Audio, all of it.
Okay, so this is where it gets really interesting for me, the armored part. The specs read like this thing was designed to be run over by a tank. What is actually protecting those tiny glass fibers?
This is truly the aha moment. So you have your 8 optical fibers inside a 4mm plenum-rated jacket, but then you get the layers.
The armor.
The armor. It's a stainless steel corrugated tube.
Right.
And if that wasn't enough, it's reinforced with Kevlar.
Kevlar? Seriously? So how does that translate into actual strength? Like if I'm pulling this through a wall.
Okay, so they give it a crush resistance rating. The long-term rating is 500 newtons, which is like having 50 kilograms or about 110 pounds just sitting on it.
And that's long-term.
That's long-term. Short-term, it can handle 2,000 newtons. That's 200 kilos. Think of a heavy medical cart rolling right over it and not even phasing it.
That's insane. And this protection carries over to the connectors too, doesn't it? Because a tough cable with a weak connector is useless.
Precisely. They're 24-karat gold-plated, which is nice, but the real feature is their K-lock system.
K-lock, what does that do?
It provides 15 pounds of restraining force. So once you plug it in, it is not coming out by accident. You have to intentionally pull it.
Perfect for those mission-critical spots where a loose cable is a disaster. But that brings up a really important technical detail, power.
Yes. This is an active cable. It needs electricity to do all that signal conversion.
Right. So where does it get the power?
Good question. And it's the one thing you absolutely have to plan for. The source end, which they label connector 1, can usually pull enough power from the HDMI port itself.
But the other end?
The display end, connector 2, is more power hungry. It has a little USB Type-A pigtail that you must connect to an external power supply.
So you need a USB port or a power brick right there at the display.
You do. You have to have power available at the screen. No way around it.
So let's tie this all together. You have the performance of fiber optics, giving you perfect 4K video over huge distances. And you combine that with, basically military-grade physical protection.
It's for that intersection of needs, right, where you need extreme distance, signal perfection, and the cable has to survive physical abuse.
So we've mentioned medical and industrial settings, but that leaves a final thought for you to chew on. Considering that you have to run external power to the display end, which adds a little complexity, what other kind of critical infrastructure would demand this level of armored protection, where a signal loss, even for a second, would be catastrophic? Maybe think about something like a high-security data center or maybe an advanced flight simulation rig.